Hello, welcome, happy Thursday. This is Timon from Google for Startups. I'm very, very happy to welcome you all to our Startup School Week 2. Today, we have a special, advanced, interesting topic. The fourth sessions is about scaling. We're going to scale our generative AI. We're going to show some advanced patterns, advanced production techniques. I'm very happy that so many of you are still with us. This is the program that lasts for 4 weeks. We're almost in the middle, and I'm really, really excited to see familiar faces, familiar names on the chat and Q&A panel. We are, as I said, on the week 2 right now. We have still cool and great lectures in front of us. We are going to have week 3 where we're going to switch to BigQuery, and then we're going to have a week 4 we're going to have our guests from Anthropic and Google DeepMind sharing their expertise on their products. Before we go into the class, those that are here, not for the first time, you know the drill. I'm going to tell you a little bit about the structure. So the Startup School Gen AI is a series of live sessions happening every Tuesday, every Thursday on the same time in the day. They are available to watch on demand, and we will ask you to do your homework, because it's not only these live sessions that you're attending right now, but it's also access to Cloud Skill Boost, where there is a list of recommended labs and notebooks so that you can practice what you've just learned. Now, a couple of things about Cloud Skill Boost itself. Most of you already received the credits. It's a fantastic platform. We have sent information how to redeem credits to that platform in an email, confirmation email, and a reminder email. If you still have some troubles, shoot us an email, scan this code to get that unique URL. But please follow the instructions under this link very directly, step by step. This is the guarantee of success. Cloud Skill Boost is a great place, as I said. There's a lot of courses, a lot of labs that are available for free, but some of them that you need to use computing power require a couple of credits. And with this program, we are granting you 200 credits, which should be more than enough to practice almost all the labs for the couple of next months. Before we jump into the session, just 2 more things. Our housekeeping rules. You're not new. For all of those that are new, just a quick reminder. On the right-hand side, you have a chat, and the chat is there for you. Please do not spam and flood with the LinkedIn. I kindly ask you not to, but just share experiences and talk to each other. I'm going to be there on the chat all the time as well. But the more important place is this Q&A panel just down below me. If you scroll a little bit, you will have an opportunity to ask questions to our experts. We do have a little army of AI experts that are there to share their experience and answer all of your burning questions. So use the opportunity. This is recorded, and the slides won't be shared. This is recorded, and at the end of today, it's a beautiful morning here today in Malaga, where I'm calling you from. So during the evening, in a couple of hours, this is going to be available on demand. If we're sharing and if we're showing labs or notebooks during the session, please do not try to attempt and finish them along the instructor. You have time, you have credits, take your time later on. Okay, last but not least, we have chat, we have Q&A, but once this session is done, how we can talk, how we can stay in touch? Well, we do have a Discord channel. So I'm happy to invite you to join the whole thing is called Google Developer Community. But under this specific link, or when you scan the QR code, you will find our own Startup School Gen AI channel, so we can stay and keep in touch. With that, let me just invite our fantastic speakers today. We have Turan, a black belt of generative AI, and Haran, a customer engineer specializing in data analytics. Gentlemen, it's of course a great honor, and I'm very happy to have you here. It's not your first startup school, you know the drill as well. But please be open. Let's share your knowledge with our audience today. I'll leave the intros and the further presentation to you. And I will see you in about, I think, an hour and 10 minutes. so that we can have a short Q&A. And to all of you, yes, if you want to ask some specific questions, these two gentlemen, please write them down in the Q&A panel. Over to you.
Yes. Thanks a lot, Timon. And then welcome, everyone. So even though I cannot just interact with you directly, but then I know you exist there. So thanks a lot for just joining early in the morning of a gloomy, let's say, Thursday in Amsterdam. So I'm here together with my colleague, Harin, and then we will be just talking about the scaling generative AI solutions, focusing primarily on advanced pattern and production techniques. So just to give a quick introduction to ourselves. So I'm Turan. I'm actually, like, in the meantime, in this preparation, I became a manager in my team. So I'm head of black belts as well as solutions architects. So a small correction there. And then I will also leave it to Harin to introduce himself.
Hi, thanks, Turan. Hi, everyone. I am Harin. So I'm an AI specialist customer engineer. I am based out of Tokyo. At Tokyo, it's 5 p.m. right now, really nice evening. And I'm very happy to spend this evening with all of you. Today is going to be a slightly advanced session. So my session is going to be the second half. And the first half will be led by the Turan. So hopefully I'll see you in the second half of the session, and hope this session will be useful for all of you. Thank you very much.
Great. So here's a brief outline of the talk that we will be just talking about. We will be looking into the advanced patterns with the context of agents. And then this is actually, if not the most interesting part of generative AI today. So, and then we will be next moving on to the, let's say, production paradigms, which will be told by Harin himself. And then last but not least, we are just going to be doing something very interesting, visually appealing. And then Harin will be also just talking about how Imagen 3, you can just generate like quite some cool pictures. So without further ado, let me just dive in directly. So it's all about like advanced patterns with agents. So I just want to just start with a disclaimer. This is going to be advanced. So if you're like worried about if you're worried about just not being able to follow all the topics all together, that's perfectly fine. We are going to be talking about the edges of the technology as we speak today. This is, if not the most hot topic that I see, that I'm just working with and with my team every day. And it is really dear to my heart, but then it can get a little bit sophisticated, but I'll try to be as simple as possible, but then just be prepared about what's incoming, right? Then let's just dive in, right? So generative AI is transforming how we are interacting with the technology. And then it has been there for quite a while, but then it has gained quite a lot of popularity in the past 1.5 years, where my whole life has also changed dramatically with it too. But it is becoming something very tangible and very usable in everywhere. And then let me just begin with a brief history of the LLM applications. And then by brief history, I mean like 2 years, which is, let's say, like decades in LLM world. And then if you were to look at how this whole started, it's just like, we were just working with models, and then we were just interacting with the models and asking questions. And then the model had a lot of internal knowledge that it has some capabilities already with coming from their billions and billions of parameters. And then when you ask a question like, what is a pixel tablet? It was just digging deep into their knowledge base, in their internal knowledge base, and then just spits out an answer. And then we don't know that there might be some hallucinations, but mostly not. And then they were just saying that, okay, the pixel tablet is designed by blah, 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 blah. So this was a very typical, let's say, autocomplete version of things, right? So this technology is as smart as is. It has been there for quite a while, people using WhatsApp and text messages when you have the autocomplete. It was similar to that, but it was a lot more smarter than that. But then we just incorporated something a little bit new to the mix by introducing these, let's say, RAGs, retrieval augmented generations, where we are just leveraging data to complement the model. And then now, instead of just digging deep into the model's knowledge base, we are now also able to extract information externally as well. So which caused us, let's say, less hallucination, supporting the model's knowledge with the external knowledge. which made this which made the whole thing a little bit more sophisticated, but also a more robust in quality. So, for example, when you're asking a question of what is a pixel tablet, it just goes back to the vector database alongside with its knowledge, and then extracts that information and generates it and sends it back to the user, right? But what we are going now is the most interesting part, which is what we call generative AI agents. And now, instead of just retrieving, digging down into their knowledge base and digging, like extracting information directly from somewhere, it is now able to do reasoning, and together with orchestration, it just not only generates information, but also does things, right? And today's talk will be all about how this works. So, for example, like right now, we will be just asking a question of what is a pixel tablet. Then we will just do some sort of an orchestration, and then the model by itself will say, okay, let's query with Wikipedia, and then just go and then use the tool of Wikipedia, and the tool will say something. Okay, there is this pixel tablet, and then it will analyze this information, and then the model will just reason what to do with that information, and then just generates a result. So today's talk is all about this, like my part at least. And then this is where the whole, let's say, the frontiers of technology lie, because basically up until today, everything was quite straightforward for like a more advanced version of all these things in the past. But now this is bringing a very interesting like a paradigm to the whole game. And then especially for startups like yours, this is, I think, where you should be just focusing on. But more on that. So like what do these agents do? And then like built on top of a model and a platform and an infrastructure, they will be able to just do specific tasks and then conduct those specific tasks. And then what would those tasks would be? Like a customer service, like employee HR agents, like creative agents, just doing something, not just create a picture, but then does a lot of tasks simultaneously. Or data agents, where you can just ask questions to your data, but do something with it too. And code agents, where you can just ask it to write code, but also execute them. And then, like, you know, the possibilities are infinite, right? But let's just break it down a little bit. What is a generative AI agent? A generative AI agent is defined as an application that tries to achieve a goal by observing the world and acting upon it using the tools at its disposal. So actually, one thing that is important here now is that we are talking about now applications, not models anymore, right? So because it's an application that does things, and then it observes the world and it uses tools along the way, right? And then if we were to break it down into two, let's say, interaction types, we have like the very well-known conversational agents, right? So these are, let's say, Q&A agents, chit chats, world knowledge interactions with humans, and then these are very well-known use cases that we know. But then, on the other hand, we also have agents which are workflow-oriented, and then they don't have to interact with the humans. Like they are triggered by events. So, for example, something is happening in the backend systems and then triggers an action, and the agent takes action against that triggered event, right? And then it just does tasks automatically. Like you can just think about this from a RPA, robotic process automation perspective. So they do tasks independently with no human interaction. But also we have, on the other hand, we have conversational agents, which is interacting with a human and does tasks and fulfill their user queries. So let's just break it down, this foundation, like a generative AI agents, into foundational components. So let's say that, and then we will be primarily, like, we are oversimplifying this because this is already quite advanced on its own. So I will be just focusing on the conversational agents, but then the principles apply equivalently, say, to with the workflow agents as well. So we have an end user. It can be an API or a real human, which sends a query, and then it just sends a response. That's what an agent does, right? And then within it, we will have three components. The first component is a model. And the model is used to reason over goals, determine the plan, and generate a response. This is the, let's say, not the brains, but then the execution of the this is where the whole LLM models are working, right? And then we also have this thing called reasoning loop, and then basically they are creating this observation capability within the agents, right? So they have goals, they have instructions, they have also short-term and long-term memory that keeps track of what happened in the past and then starts acting accordingly. And then basically with this information, they start reasoning and planning about what the incoming request is all about and does some action along the way. And then for doing that, they also need to utilize some tools. And then that tools would be fetching data, it will be performing actions or transactions by calling other services through API services, right? So this is kind of what the agent runtime is all about. And then we will be just diving deep into all these three components separately. I just put this picture here just to make it a little bit more simpler as well, so that we have three components rebranded as reasoning loop, tools, and model. Okay, let's dive into each one of them. So the model are known, the models are just the things that we know already. Like this can be Gemini Pro, Gemini Flash, or your Tune models, and any external model as well. These are just something that you are already using today. So there is not much of an elaboration needed for this one. They just play the, let's say, the execution side of the agent itself, right? So they just orchestrate like information coming from the reasoning loop. They just execute on it, and then they just take action alongside as well. If you were to look at the tools themselves, so we will be focusing on within the Google Cloud setting, we have three types of tools. We have extensions, we have functions, and we have data stores. And then what those three tools do, they allow agents to interact with the external data and services, right? This is like just to put it simply. So when you ask a question to an LLM model, asking what is 2 plus 2, it shouldn't just dig through its own let's say knowledge base and then come up with the answer like it is 4, but it should know how to use a calculator, if you will, and use that as a tool, and then send the command of push the button 2 and push the button plus, and then 2 again, and then equal again, and get the result, and get the result of 4, understand what it does, and then respond by saying it is equal to 4, right? So these are a very simplified version of what the tools essentially do. So it can be through, let's say, like this is one example of tools where it is talking to an external party of an APIs, but this can also just extract data, just like in a RAG setting, right? So these are the three types of tools which we'll be further digging down into further. And then the reasoning loop is basically where the most interesting part is, right? This is where this whole agent framework is differentiating from everything else in the past. So what do they do? So basically, they just reason through their, let's say, goal setting, and then also their personas, and then their techniques. So to understand what the incoming request is, and then they connect complex thought chains to one another, and then they just reason on what the incoming query is about. So when you ask someone to some question in the back of our minds, we just don't come up with an immediate answer. We just break down the problem into chunks, and then we think iteratively, and then we just come to a conclusion. And then there are a lot of algorithms out there. So you see at the bottom, like 4 of them as an example, like the React agent, chain of thought, and tree of thoughts, and directional stimulus prompting. These are just examples of how a reasoning loop can work in the background, right? So this thing is already sophisticated. I'm not just going to go into the details of it, but then my favorite one is a React agent. This is a paper from 2021, as far as I remember. And like I might be completely wrong as well, but then it is a paper by us, at least that's what I know. And then and it just is embedded in most of our tooling, right? So let's just go through a basic agent operation. So what happens, right? So you just send an easy user query, and then it just goes through all these 3 components, and then it just generates a response. From an input-output relationship, there is nothing fancy about this. But what happens in the background? So let's just think about an example of an flight booking, right? So let's say that the user says, I want to book a flight from Austin to Zurich. And then what happens in the background, the reasoning loop just takes that input, i.e. that I want to book a flight from Austin to Zurich, and then it just starts thinking about this. Okay, now, if the question is, I want to book a flight, I should search for flights. Okay, so if I should search for flights, that means that I need to take action by sending a query to a flights tool, like, because you see that on the right-hand side, I have my tool set. Like I have flights, I have search, I have code, I have calculator. So among that, I need to choose the flight tool. And then basically, I need to send something to that, right? And then that would be a flight from Austin to Zurich, most probably in a JSON format, right? And then I send that tool, this input to that tool, and then the tool does something and returns something back to me. And then basically, the observation of that would be like, okay, this is option number 1, option number 2, and vice versa. Okay, so and as a model, as the reasoning loop, I send, okay, so I should present, like, what do I do with this information? Then I reason, saying that I should present these to the users, and then I generate my final answer, and that would be, here are some flights that is coming from the tool, and I just push it to the end user. So this is how a very simple single agent works, right? Let's just go into the extensions, like the tools themselves. So like I mentioned, there will be 3 ones: the extensions, functions, and data stores, right? If you were to look at the extensions, so we have an agent, and we have, for example, like the Google Flights API, right? So you need to connect them somehow. So one of the ways of just doing that is through extensions. So this one is some sort of a tool that at its disposal that connects the agent to the external Google Flights API. And this is most probably a public one. And then, for example, if the user asks for get flights, then it just generates, okay, if the API requires, Google Flights API requires get flights function, and they require argument 1, argument 2, argument 3, I need to generate all of that. And then through my integration with the Google Flights API, I just send a function, and then I send the input, and then I'm expecting to get the results directly from this a Google Flights API, and then I will generate my results. And then the way to do that is through generating an OpenAPI YAML file where you just list what the parameters needs to be highlighted and then used. And then I'm just using something like a Flask that just talks directly to the Google Flights API within it. And then all of this is consolidated in the extension itself, right? So this is what we mean by extension. And if you were to look at what the functions do, they are very much similar to the functions, but then sometimes you don't want your model or your agent to access something very secretive. So which means that you need some sort of a middleware that does all those access to, because basically you don't want to give, for example, your secret API keys to your model because they can be hacked and it's not like super safe. And then basically instead what you should be using is a function. So that function then interacts, instead of directly talking to the, let's say, the external API, it just talks to a middleware, and all the security is just being handled through that middleware, and that middleware talks to the super secret API. So what this agent function needs to do now is to generate a JSON file, and Haren will be just talking about, for example, generated outputs, guaranteed outputs. Yeah, he will just talk about that. My bad on the conventional names. That ensures that the input needed for that super secret API is sent properly to that middleware. So what it does is that, like, if we were just going to be talking about like a flights, then it will be just generating arguments needed for middleware that sends a request to the secret superware, and the middleware itself does the task. Okay, and then the response is back the request here that you see on the yellow, green here, is sent to the super secret API. It generates a response, and that response is just going back to the agent, and then the agent generates its response back. Okay. So basically, in a nutshell, the extension, the only difference between extensions and function is the necessity of a middleware. So if you if you have if you don't need a middleware to talk to a super secret API, then you can just do an extension. You build all the let's say function calling directly in the agent itself, or you just want to be secure, and then there's some sort of a super secret API that you might need a middleware, and then that's when you need to use the function. Okay, but in its essence, these are just, let's say, ways of just talking to an external API, right? Extensions and functions, they talk to APIs, and they just let the API does whatever it needs to do. The agent just uses these tools to generate relevant information for the end user. Okay. If you were to look at the data stores themselves a little bit, so this is the last tool that exists. So these are just like by utilizing a vector database, you can extract generate an index of information from private documents, from public websites or intranet websites, or structured data, which is created into first converted into embeddings, and those embeddings are stored in a vector database. And then basically when you send a query saying what colors does the Pixel 7 come in, and then they just go back to their database, do the, let's say, the closest neighborhood search, and then comes up with a list of answers. And then basically then it just the agent again takes that information and then just sorts an answer. So actually, if you were to think about the rack stuff that you might be very familiar with, they are also an example of agents, right? So instead of just the API tools, they're just using vector-based databases. And then if you think about the vector database to be an API, that's also another API tool on its own. It just generates data instead of actions, right? So, and then in that sense, it is just working very much similar to what an agent does. So if you were to look at this, so this is just scratching the surface, right? So the agents can do a lot of things. You can just give a lot of different tools and different agents alongside as well, and then you can make a very sophisticated cognitive structure. And then just to give you a little bit of a few sample architectures, this is just one example of it, right? So you just create a custom UI, and then the custom UI talks to an agent, and the agent itself has a lot of, let's say, tools and then examples, and then they just with that orchestration reasoning setup, it just talks to a model, and that model talks in turn to tools. It can be a function, data stores, or extension, and then basically those things return results back to the model, and the model just agent generates results, and then basically gets back to the end user somehow, right? So this is a very, very oversimplified architecture about how this works. But then as we are just going a little bit more straight, like a simple, from simple to more advanced. So this was a very much what I showed earlier. The examples were all a sample of simple single agent architectures, right? But if you were to go a little bit more sophisticated, then we can just talk about multi-agent architectures. And then the multi-agent architectures are quite interesting because basically, instead of just sending everything to a single agent, you can just divide your complex task into smaller, simpler, smaller agents that does a very specific thing on their own, and then they just consolidate somehow the information into a multi-agent architecture that does something, right? If you're not confused enough already, this is going to get a little bit more confused next. So we are talking about two simple multi-agent architectures. So what would be the first one is a collaborative agent. So let's say that there is a user query that comes in, and then it just queues the messages, and then basically this queuing is just sending all that information to all these parts of different agents, and those agents just does some collaborative action in between them, and then come to a final conclusion, and then sends the user response back, right? This is way like the agent A, B, and C, they just collaborate with one another, and they do multiple tasks simultaneously, and then they just generate one one final, let's say, answer to be sent back to the end user. The other one is, which I will be just showing a demo for, is a top-down supervisory one. So this one is more like you have this, let's say, orchestration steering agent, which just has multiple sub agents in the background, and that does specialize in a specific task. And those agents also talk to other agents, and then there's a kind of a decision tree of what the agents are doing simultaneously. And then the orchestration agent is the customer-facing agent that does orchestration among all these different agents, and then consolidates all that information, and then does the whole final answer. And then basically, for example, this is also the point where they do the evaluation of all the underlying agents, and then checks whether the information coming from the underlying agents is good or not. And then basically they orchestrate everything all together. And then I will be hopefully just showing you a demo if the demo gods are just with me today. Okay. So let me just share my demo screen, and then I will just show you a very, very oversimplified demo on Vertex AI agents. So we are at the Vertex AI agents agent builder, and then what you see here is a managed service, which is on top, like that abstracts away everything that I mentioned, and then this just does it already on its own by itself, right? And then what you are seeing right now is a multi-agent structure about DMV. DMV is Department of Motor Vehicles in the US. So what they do is that they just do the very interesting work of like issuing driver's license, and then like renewing driver's license. They can book an appointment, and they just work with your, like this is where you go, and then change your driver's license, and then register your car and all those things, right? So this agent is meant to do a lot of things simultaneously, and this is an example of an multi-agent structure with orchestration and steering in mind. So let's just, you see that I have a steering agent, and then I have three other agents. One is a renewing driver's license agent, the book appointment agent, and a fallback agent, right? So if you were to look at one of the first agent, so you see that I have an agent name, I have a goal, and I have some instructions. So if you see what the instructions are, it's just saying that greet the customer, tell them you can help with the renewing driver's license, booking appointments at field offices, and ask them how you can help. And then you're just giving like a bullet by bullet what to do and what not to do. And then basically you're also just pointing towards other agents. So for example, if they're asking to renew their driver's license, go to the agent renew driver's license. And if they want to book an appointment, then go to the agent book appointments. And then if anything just doesn't work, go to the fallback agent, right? So this is just like steering the agent towards other agents in a completely like in a human language way. So you don't need to write code if this and that. You just tell it what to do. Like you're explaining to the steering agent what to do directly. And then you also have like introduced some of the examples, like you know what to do and how to do it. And then basically, if you were to go and look at the other sub agent, which is a renew driver's license, it is very much similar. You just have an agent name and then a goal. And then what you see here is that it has the same, let's say, instruction setup, like a step-by-step explanation. But then I'm also just introducing tools. So for example, this one's task is to renew the driver's license, right? So, and then I'm just saying, like, if you come here, collect the informations and collect the customer's information and verify them using the tool called DMV Renew tool. This is an API call. And then basically, it just does the tasks afterward. But what I would like to just show, I will also just tell them that this agent is using the Renew tool. And then basically in the tool side, what I have here is that I have just generated a schema, right? And what the tool does and what information that it needs to do to come up with this let's say, to fulfill the requirement of renewing the driver's license, right? So you see that there's a schema, just says that this is the info, what the title of is, where this is the servers, like which it will be talking to, right? And then if you talk to this, like the tool, which I will show right after, it needs to do, let's say, different paths. Like it can verify driver's license, and then if it does that, like it needs to send these parameters, and then the schema that it needs to just generate. The required parameter is the driver's license number, for example, and then it just generates this response. And then you have a different path with a verified expiration date, and all these, let's say, other information that this tool does. So in the background, what I also have a cloud function that does this thing, right? And then if you were to look at this DMV book appointment, I just created a cloud function that does the sort, that has its source code where I just identify what this tool does. Right? This is a Flask, let's say, a very simplified Flask app that does different things, and then it can get the office info or validate appointment date, or it just does other functionalities that's not a part of my, let's say, demo. But then I just get the if I just come to the path of get nearby DMV offices, this is the function that it does. It just selects the DMV office, and then such as appointment dates and so forth, right? So if you were to look at how this works in its essence, so let me just show you this example. So I literally created this conversation yet again today, and then basically if you were to look at this directly, this is what I have created. So if I am going to say this conversation, so I said hi, and then the steering agent is just coming back with the greeting saying that I'm your DMV assistant. I can help you with renew the driver's license today and book an appointment. How can I help you today? And I say, I'd like to renew my driver's license. And then now it just reasons that it needs to go to the agent of renew driver's license. And then basically it just goes to the agent of renew driver's license. And then it needs to, is following the instructions in the renew driver's license, it just needs to ask, may I have your driver's license, please? And then I respond back by saying this ABCD1334. And then now it reasons to use the renew tool. And then it just generates this input, the driver's license number, and then it sends it to the API call, the function that I just generated. And then that function generates this: verify results, driver license found, expiry date. And then it just understands this output and then just says, okay, thank you. I found your profile. Please provide the expiration date of the license according to the instructions that I just mentioned. And then it just goes back, and I respond back with my, let's say, the expiry date. I just made a mistake because I should have said 2023 because the cloud function doesn't have the expiration date of 24. And then it says, no, I don't recognize that. Can you just repeat it again? And I said, okay, no, it needs to be 23. And then it just comes back with the expiry date of this. And then now I found it, I give it a success. And then I move to the next step. Tell me your name. I give the name. It just asks for the date of birth. I give the date of birth. And then now it has all the information that it needs to fulfill to cut. I'm just, if you were to look at these steps, it is now following all these steps, and then it just needs to verify the information. And when I just verify the information, then it says, okay, you have successfully applied for a renewal of your license, and then your confirmation number is blah, blah, blah. This is randomly generated number. And then it just asks for anything else. Can I help you with today? Again, following the instructions here. No, I'm done. Okay, have a great day. Okay. So this is, in a nutshell, how a multi-agent architecture works, right? So I have the steering agent that talks to the renewed driver's license, which utilizes tools at its disposal, such as booking an appointment, and then works with that tool multiple times back and forth, and then follows their instructions to fulfill a request, i.e. booking an appointment for the end user, right? So if you were to come back to the slide deck, so this is in a nutshell how agents work. So this is, again, a very simplified version of how the agents work, but then there is a lot more to this, because there are a lot of topics that I haven't touched base yet. And then this is just the scratching the surface, because if you want to do this in an enterprise setting, then things become a lot more sophisticated. And then, because basically, if you think about this, LLMs, let alone being agents or not, they're just like a very simple API called them by themselves. And we are hyper focused on this one. But then if you were to look at the complete ecosystem that would be needed to make this LLM work properly, it is a huge thing on its own, right? So you need to think about the evaluation of the models. You need to generate analytics. You need to start logging things. You need to build this into a CI/CD pipeline. You need to think about the grounding. You need to create different agent types. Are you going to be using React or chain of thought, or how do you ground it? And then this ecosystem gets a lot more sophisticated. So the reason why I'm just telling this, because I'm just trying to transition to what Haren is going to be talking about, because building a Gen AI application on its own is a very difficult task on its own. So that's why actually next, Haren is going to be talking to you about how to optimize all these things for production. So going back, Haren, you're back here, I guess.
Yeah. Thank you, Turan.
Thanks a lot.
Okay. I think Turan talked a lot about agents, and which is going to be a key, I think, for a lot of Gen AI apps in the future. So what I'm going to talk about is, when you build a Gen AI app, how do you optimize that for production? You need to make sure that your Gen AI app is fit for production and it will not cause any problems in the production. And also, unless you put your app in production, there is no value in the app, right? So actually taking the app to production is also very, very important. And there is a lot of cases where the apps don't go to production because they do not satisfy all the criteria. But without the app going to the production, the app has almost no value. So I'll talk a little bit about what it means to take an app to a production. So when you take the app to production, you need to make sure that the app is reliable, it is scalable, and it is secure, right? So these are the things that we need to make sure to take the app to production. And what I'm going to talk about is some of the tools that we provide in GCP that will allow you to take your apps to production in most reliable and secure manner. So the first topic I'm going to talk about is provisioned throughput. So I think, all of you, I think, who have been using the Gen AI APIs for a while, that there is this thing called quota. All the Gen AIs have quota. And after you run out of quota, you are not able to use the APIs anymore. And while this is okay if you are just experimenting, but if you want to take your app to production, this is unacceptable, right? So you need to make sure that your apps are running all the time and the users are actually being able to use the app all the time as well. So there needs to be this availability guarantee. So provision throughput is a way to achieve that. So typically, when we want to take the Gen AI apps to production, so Gen AI, as it's got like billions and billions of parameters, right? So it takes a lot of resources to host those models, right? Which means it's consuming a lot of resources. And right now, one thing we don't have in the world is enough resources to run the Gen AI models. So a lot of customers, they run into these challenges. One is the quota limits. So you have an app, you put the app in production, and then you suddenly see this influx of traffic where you see lots and lots of users just trying to use your app, but you cannot serve it because the server is not able to handle it, right? And the other is, a lot of the times, right, even if there is a capacity, the service is not always guaranteed. It is best effort basis. So there is no SLA, right, for that. So this is out of the problem for the users, right? So the user is trying to use the app, but there is no assurance that the app is going to run 100% of the time. And then the other one is unpredictable spend. So when you put your app out in the wild, right, anybody can access it, right? Any users in the world can access it, and bots, right? I mean, they love this sort of things. Or maybe like, you have an attacker, who just is sending like out the DDoS attacks, right? So um, so when you are just using this app without any sort of protection, that means your spending bill can go up really, really quickly. To address this challenge, we have this thing called provision throughput. So provision throughput will provide you a dedicated capacity and provide you an assured throughput. That means you will have a certain amount of throughput that is assured by GCP. And also there is also availability of service SLA, which means the service that we provide is not just best effort, but it is actually backed by an SLA. So which is great for the users. And then the cost is fixed. So even though your apps can be used by lots and lots of customers, and you might get some attacks once in a while, right? You'll always have the fixed cost, which means you'll only pay for the amount you bought, the capacity you bought, and within that capacity, you will not pay anything extra, even if you have lots and lots of requests. Just to put it in the picture, right? So there are two things you're going to compare with. One is like the pay-as-you-go architecture, and the other one is the provision throughput, right? So in pay-as-you-go, as you can see, it is shared by all the customers. So that means like the resource availability is really based on like how many customers are actually using it. And for the provision throughput, you have a dedicated capacity, which means like you will have a certain amount of throughput, which is backed by SLA for you. So this is one way to make sure that your app runs properly in production and your customers are not impacted by any sort of availability issues. The next one I want to talk about is context caching, right? So what is context, right? I think for the people who have already used LLMs, you have some idea about like what context is. LLMs, so you put a prompt inside an LLM, that is a context, right? So the contexts are getting like more and more complex, right? What are the things that are part of the context these days? Is the one is the configuration. So which means you have the model version, you have like the parameters like temperature, top P, top K, and things like that, right? And also the tools, like the types of the tools that you want to use inside the LLM, right? And then you also have these things called system instructions, which means you want the model to behave in a certain way, and you need to instruct the model to provide the answers in a certain manner. So you need to provide system instructions for that. And then you got the content, right? And as you know, right, Gemini allows up to 2 million tokens in context. This is a lot of tokens, right? Which means like you can provide up to 2 hours of video. This is great, but if you start to send 2 hours of video every time when you are making a request, it is going to make up a lot of cost, and it's not always efficient, right? So what we do is we provide this feature called context caching, which means if you are using a large context every time on a request, instead of sending that context every time, what you can do is you can cache it somewhere, right? You can cache it inside our system, and you can reuse that cache. And if you do that, the cost can go down by up to 75%, which is quite a lot. So the flow here, you can say without caching, there is a flow mentioned here, is you just send everything, all the context every time you send the prompt, and then you just do it as usual, right? But if you use a cache, what you do is you only send the part of the prompt that's changing every time, and then the actual context, which can be like a PDF file, it can be a video, it can be a large file or an image or list of images, right? All these things can be cached inside our system, and they can be used on demand. So this can reduce quite a lot of cost, and especially in production, when you getting a lot of requests, this becomes a key. So a few things to take care of when you are using the context caching is, one is the size limit, which means like you can only cache the content that is over 32K tokens. So So you might ask, like, why 32 tokens, right? 32,000 tokens, right? It's because, like, the context caching is useful only if you have a large file or large context, right? So it makes sense to actually have a larger context, or use it for the use case where you actually can save some money. And you can save the context for any amount of time. The minimum time is 1 minute. So next one I'm going to talk about is batch API. So this is very interesting concept, that unless you know, like, where to use, you might be wondering, like, why do you even need batch API, right? So I'm going to talk a little bit about one of my customer who is using it, right? So one of my customer has a big online, shopping website, right? And they get, like, the reviews every day. They get lots of reviews, and they also get the comments from the customers as well, right? And all these reviews and all these comments, they all go straight to BigQuery, right, in a table. And what they want to do is they want to do some sort of analysis every day, right? Now, what you can do is, you can just try to write a piece of code where you fetch each and every comment and then send it to the API, and then write it back to the BigQuery, right? You can do that, but that is not very efficient, right? So batch API, what it allows you to do is, right, take everything from BigQuery as a table, right? Put everything inside LLM, or like send calls one by one, and you don't have to do that. This batch API will do it for you, right? All you have to do is just create a batch job, and then it will pull the content from the BigQuery, and then you will send it to the LLM, get the response, put it back to the BigQuery. Next day, the site is online, and you can simply use that data on the site almost immediately, right? And to have that sort of flow, something like batch API is so useful. And I think this is something that becomes very essential for the people who want to take their application to production. The next one is control generation. So earlier, we're talking a lot about agents, right? So we're talking about, like, chaining the agents and getting the response from one agent and then feeding the response to the other one, right? So this whole process is only doable if you can have the output in a controlled manner, right? Every time you get an output, if you cannot get the output in the most reliable manner or the reliable format, then it becomes less useful. You can probably manage it, but it becomes, like, more. You have to do lots of more custom things, and it becomes, like, more tiresome. And what Gemini, Flash, and Pro provide is the output that's almost, the format is deterministic, so that you can get that output and then use that output in the other system or in the other component. Just to give you an idea of what exactly this is, right? So what you do is, first you set a schema. So you say that, okay, I want response in this particular schema, right? So this is what you do, and then you send the prompt along with that schema, and Gemini, Flash, and Pro will always give you response in this particular format. Now you can simply parse this code, right? This JSON file, this JSON response, and then use this JSON response to use in the other component, or use a part of your big system. And this, again, in the production system becomes a very, very important thing. So another part, like this, which is really, really important, is the evaluation, right? So I have talked to, like, many customers, who have built like chatbots, for instance, right? And they are very scared to put that in production because they don't know what kind of answer the users might get, right? They think that maybe the chatbot won't give the right answer, or the chatbot might behave in a strange way, that unexpected ways, right? And because of that, a lot of customers are very hesitant on putting the chat apps to production. But I think we need to be more pragmatic about that, and we need to handle this thing in more methodic, more systemic way. And Gen evaluation will help you to do that. So when you are going to put a production put a model to production, right? So what we typically do is, you get a pre-trained model, right? And then you extend that model. You feed that with your own data. You attach that to your application that your GenAI app needs to connect to. And in order to get this function going, you might sometimes need to customize your LLM. So in GCP, we provide multiple kinds of customization options, things like supervised tuning, fine tuning. We also have something like reinforcement learning with human feedback, and it's in preview. But we also have this thing called model distillation, where you can use very small model to learn from big model to have almost a similar capability as a big model. So once you have that, right, now you want to put that in production. What you need to do is you need to make sure that the model is behaving as you want. And to do that, we'd have to evaluate the model. So how do you evaluate the model? So to evaluate the model, so we have three key things that's required. One is the task that you are evaluating the model for. So each model, each application will have its own particular purpose, right? Maybe you are summarizing, maybe you're doing a RAG, right? You are doing a Q&A, something like that, right? And then you have your own context, which means you have your own data, right? You have your own data, you have your own environment, and then you also need to have a criteria, right? So you have a set of business goals that you want to achieve with the model, and that becomes your criteria. So with this information with you, you can go ahead and you can start evaluating your models. To evaluate Gen AI, right? Just to put this in perspective, right? So first of all, you have your prompts, and then you try to find the model if the model is good for your use case, and then you try to add some knowledge to your model, right? To your own private knowledge to your model, and then see if you need to tune, right? And then you do evaluation, and then you can run this loop, right? And once you have the satisfactory result, then you can launch. So in Vertex AI, we have this thing called Gen AI Evaluation Service, right? So this supports, like in the Google's foundation models, open models, the proprietary models as well, foundation models, the third-party models, and some custom models as well. And so you can do evaluation online and batch. And so the criteria that that can be used to evaluate the models that we have right now are the point-wise and the pairwise. So I'll talk a little bit more about this. So one of the evaluation criteria is the point-wise, which means like evaluating one model at a time, right? So you have some evaluation metric that you want to achieve, right? So you need to score on a model, right? So you have a task, and then you need to get a final score on a model, and then you want to evaluate the model on those criterias. So you can use point-wise for that. And for the pairwise is basically comparing two models, right? So you have one model, and then you have a new version of that model, or you have the other model that you want to compare, right? And then you want to see which model is best for your production environment, right? For this, we can use pairwise evaluation criteria. And there are two kinds of evaluation methods, right? One is the computation-based metrics, and the other is model-based metrics. So for the computation-based metrics, I think a lot of you might already be quite aware of things like Blue, Rogue, or F1 score, right? So typically, you have a mathematical formula that you can use to compute the scores. This can be very quick. Computing a mathematical score is not so hard, and this can be quick to evaluate. So for certain use cases, this can be very useful. And these days, the model-based metrics is starting to become more and more popular. So what you do is, you actually utilize a model. It can be an LLM, right? And use the LLM as a judge model, and use that model to see if the other models are performing as well or not, right? So you can have metrics like the summarization quality, groundedness, verbosity, things like that. So with Rapid Evaluation SDK, this is also available in Vertex AI right now, right? So it's a tool. It contains lots of metrics already, right? Built-in metrics, built-in libraries, and you can quickly evaluate a model, and you can also visualize the model within the Vertex AI. So the process, the whole process runs a bit like this, right? So what you do is you create an evaluation data set. I think this is the most important bit, right? So a typical evaluation data set contains a prompt or any kind of question you want to give to the feed to the LLM, right? And then an expected answer. And so you call that ground truth, right? So that's the information you use to evaluate the answers provided by the LLM. And then you create a task, eval task in Vertex AI, and all the results are logged in Vertex AI, and you can visualize everything, and you can see which model is good for you. The other one, really interesting one, is the auto side-by-side. So this is used to compare two different models, right? So typically, like, when you are trying to adopt a new model, right? Or you already have an existing model and you want a new version of that model, right? So in that sort of scenario, you want to make sure that, that the one model is performing better than the other, right? So you can compare those two models using this thing called auto side-by-side. So this is all fully managed service, right? So what this one has is the key part of this thing is this thing called auto rater, right? So this is a model itself, right? What this model does is it takes the output from model 1, output from model 2 based on evaluation data set, and then it will rate the output. It rate the output, and then it will provide you with the useful metrics, and you'll be able to tell like which model you want to use for production. So this is really useful if you want to, compare two models. Again, for this, the process is very similar, right? You have to prepare an evaluation data set, right? So basically prompts, and for that you want to fit into the model, right? And then put this data set inside the BigQuery or cloud storage, and then just run the evaluation service, and then you'll be done with that. So like you can also extend whatever I mentioned to RAG, right? So it's very similar to evaluating RAG is also very similar. But with RAG, what happens is you have typically an exhaustive list of the criteria that you want to fulfill, right? So that means you'll also have a huge amount of test data. And if you want to run all of this thing quickly, and maybe you want to run nightly, right? And you want to get the results next day because you're getting new data, and then you want to make sure that the users in production are not affected, right? So you want to do this quickly. So you can do this using by creating a pipeline inside Vertex AI using Vertex AI pipeline and Apache Beam. This way, you'll be able to parallelize all the tests and be able to produce the results in a very timely manner. So these kind of scenarios, right, where you are evaluating the model becomes very, very useful when if you just have one chatbot, maybe you'll say, okay, I'll test it and it'll be done, right? But a lot of companies will have hundreds of chatbots, right, utilizing multiple data sets. And now every time there is even a small change, you need to go through lots and lots of hoops to make sure that things are working, right? And just to pass through the quality control is going to be a huge nightmare. But if you have something like this in place, where you evaluate, you have the good metrics, and you can evaluate the models in most reliable manner, then taking these chatbots to production will be much, much easier. The next one, very really important thing, is the security and compliance. So when you are taking your model to production, right? So what you need to do is you need to make sure that your data, your model, your application, everything is secure, right? And inside GCP, all of these things are provided by default, right? Your data is your data. The data is never shared with anyone else, right? We don't use customers' data to do our training. the customer's data is customer's data. So the Google Cloud provides an extensive set of tools to make sure that your entire AI workload is properly secure. And top of that, what you can do is you can utilize this service called Model Armor. So with LLMs, especially with chatbots, right? I think there is some scope of misuse, right? Sometimes people might try to do some prompt injection, right, and try to get information out of the system that might not be that you might not want to do, right? What might not want to expose. And also things like somebody's asking about really very sensitive topics, like religion, politics, and things like that, right? So you might not want to answer those questions, right? So to make sure that your model is not giving is not responding to things like hate speech or prompt injection, response to prompt injection, right? You can use this thing called Model Armor and make sure that your model is secure, and even if it's out in the wild, your model will still be functioning properly and without any risk of damage to your company. So within GCP, right, you can make sure that your models are very, very secure. Like I mentioned earlier, your data is your data, right? You can also have the cloud security parameter, like a network parameter, where your model runs inside your parameter and it is not accessible from outside, right? And one really interesting thing about the GCP service is that there is this service called intellectual property indemnity. So for training data and generated output. So what this means is, right, for the output of our model, right, if there is any output that might cause some legal problems, some legal issues, then the Google provides indemnity, intellectual indemnity for that. Means Google will make sure that you are protected against any sort of legal cases, right? So this is one another really good thing that you need, right? Especially if you're taking a model in production, because once the model is out in the wild, you don't know how it's going to be used, right? And also responsible AI, right? The Google AIs are already they already have the responsible AI tooling. We already have the security filters, right, to make sure that the model does not misbehave, right? So all these things are very important for taking the models to production. So I talked, a lot about, taking the models to production, to make sure that the model is reliable, the model is secure, and it's also cost effective at the same time, right? So now I'm going to move on to my next topic, which is going to be slightly less dense. I think the stuff I was talking about was very dense. So Imagine 3, you're going to see lots of very beautiful images. So please enjoy this. So Imagine 3 is a model on Vertex AI. It allows you to create and edit high quality images at enterprise scale. So the newest version is Imagine 3. So some of the use cases, right? So you can use Imagine to render the images for multiple use cases, right? You can generate very, very specific image that's tailored to your needs at very high speed. You can also kind of customize the image to your own style and make sure that the image they are faithful to your brand or your style, right? So you can do that as well. So let me just give you an idea of how our customers are using Imagine, right? I'll just give you a quick demo on that. Please look at this video.
Hi, I'm Andrea Durmovic, Senior Manager Global E-commerce Photography at Puma, where sports meets creative expression. We are using Google AI to customize the product photos on our website to save time and ensure they are locally relevant to our customers. Google Cloud's Imagine is helping our global content team create dynamic product imagery. And here's how. Let's say a new trail running shoe just launched on our site. I only need to click on the Apply AI Background button. Then, based on my prompt, a variety of sample images are generated for me to choose from. Nice. These all capture every detail I included in my prompt, together with the shoe from our photo library. Let's choose this one. We also look to Imagine to help us easily customize content for regional markets. Let's say these shoes are also launching in Japan. I can localize this image by going back and editing the prompt to include a recognized.
So I think you get the idea, right? So the customers are already utilizing the Imagine in production for a lot of their use cases, at scale. And similarly, L'Oreal, they are also using the Imagine in sort of similar way, right? L'Oreal, as you know, it's a fashion company, and producing high quality image and perfect setting is going to be key for their brand image as well. And they are also using Imagine for similar sort of use cases. So the key things about Imagine 3 is the details in the image is really amazing, right? So they are the photorealistic. There is sharpness in the image. The colors are great, and it's high resolution as well. And the other one, the part of the Imagine 3 is that they stick to the prompts better, right? So even if you don't write a prompt, and you want to make sure that each and every details in your prompt is reflected in the image, the Imagine 3 is able to do that. It's able to make sure that it understands your prompt and create an image that's based on your prompt. As you can see here, right, you can see like how a card is produced. And another really key feature is that the text rendering in Imagine is really, really good. So whenever you're creating an image, especially for the commercial purpose, you need some sort of text inside the image as well, right? So it could be like like a marketing message, right? It could be you might want to generate a logo, right? Or something like that. So there is having the text inside the image, it opens a huge amount of use cases that's useful for all kinds of users, and Imagine 3 is really good at that. So I'm going to just quickly show you the demo of like Imagine 3, right? How you can use that in Vertex AI. So let me go here. First of all, if you haven't seen yet, this is the Vertex AI, right? Sorry, this is the GCP console. And I am going to go into the Vertex AI. And now you have vision. Now here we have Imagine. So I'm going to put like, a small prompt in here and see what we can get. So let me make this slightly bigger so that you can actually see the letters here. Okay, right? So what I'm going to do is I'm going to put this, a greenish yellow futuristic drink bottle with logo Slurp. Okay, this is going to be our brand Slurp, right? So I want to create an image, a new drink, a futuristic drink that's called Slurp. Okay, let's generate this. Here we go. Okay. So as you can see, like, the text is rendered quite nicely, right? And well, the whether this is futuristic looking or not can be very subjective, but it looks quite cool. Yeah, I think if anybody is a Futurama fan, right? I think there was a drink something similar. Yeah. Okay, now let me go to slightly more detailed demo, right? Okay, So if you want to use this in production, right, what you would need to do is you need to utilize APIs, right? So I'm just going to quickly show you how Imagen can be used with APIs. So I've shared this notebook in the slides as well. So you can actually utilize this notebook. And once you go through this, right, so now what we can do is we can start generating images. So first of all, I want to generate the image of a photorealistic image of the inside of an amethyst crystal on a display in a museum, right? So this is very, very simple. And so what I'm doing is here, the aspect ratio is 3:4, right? So, you can also generate like the number of images, or like, you can also control the aspect ratio as well. So once this is done, okay, here we go. This is the image we got. Looks pretty much like an amethyst crystal. So as you can see, right, this has a very photorealistic vibe, and this is the key part of the Imagen. So the next one I want to show is a beige baseball cap with good vibes written on the top in a white bubbly stitched letter that are outlined in neon green display, displayed against a pool background with palm trees and pool floats, right? Okay, let's see what we get. Here we go. It looks pretty good. As you can see again, the text is rendered quite nicely, right? This is the one of the cool aspects. And then, so the last one I want to do is, right, is the watermark, right? So by default, what we do is we attached a synth ID to the Imagen 3 images, right? So that means, what that means is, so you'll be able to know if the image was produced by an AI, right? So you want to track whether the image is created by AI or not. So using the synth ID, it is a transparent watermark that's embedded inside an image, and you'll be able to do that. So by default, it's provided in all the images, but you can also disable it by doing add watermark to false. So let me run this prompt once. So now, no watermark is being added. We got the nice ice cream store. And now what I'm going to do is I'm going to test if the watermark is there or not, right? So I'm just going to do this. I'm going to check if the watermark is there. As you can see, it says reject. That means no watermark. So in next one, what I have done is I've used the previous image, right? The image that was generated beforehand. So I'll see if the watermark says. It says accept, right? Which means the watermark was there. Yep. So yeah, so this is what I had today, right? Thanks for staying with me. I think now we can move into the Q&A. Thank you very much. This is all from me.
Thank you so much. Before we go to a Q&A, we have a commercial break, let's call it. So I'll give you a couple of minutes to take a stretch, have water, each other very soon back. I remember in Q1, we had our first Startup School edition, and we were talking about Imagen 2, and participants of Startup School had the earlier access to that tool. And hey, a couple of months later, we are with Imagen 3, publicly available, and I think it's amazing how fast these things progress. Thank you guys for the engagement in the Q&A panel and in the chat. But before we go to the Q&A with our fantastic instructors, just a friendly reminder about Google for Startups Cloud program. The rules are simple. You can build your solutions on us. Actually. So there are pools of credits that can be used on the computing power, but also on AI, meaning all these things that you've just seen on Vertex AI and our own models in Model Garden. The range of the credits varies from $2,000 up to $350,000 for scaled AI companies. So please visit the link if you're interested in this. You can get these credits and try your solutions on us. It's Google/cloud-program, or you can also scan this QR code. Pretty simple application form, and in a couple of business days, you should hear back from us. Now, I wanted to once again invite you to our Discord community. I'm there. Aaron, my colleague that is running this with me, with the sessions for Americas, is there, and I hope we can stay on our Startup School Gen AI channel during the program and also after the program. Thursdays are special days because Thursdays are the last day of this session. So we're going to ask you for some feedback as well. Yes, I think it's a right moment before we jump to Q&A. Just take the phone, scan the QR code. We have a pretty nice short Google form for you. You can also type this link in your browser if it's more convenient for you. But this is something that we can, learn from. So we would love to hear your feedback, get the grade, and our instructors as well would love to hear how they did. So once again, the QR code, I think you have enough time to take that Pixel phone and scan the QR code. Okay, enough with me. We have a couple of minutes more, and we have quite interesting questions. So I will invite both Harun and Turan back to me to this virtual studio, and we're gonna kick off with the first one that is coming from Guillermo. So Guillermo is asking for advice, basically. So I hope we can help him. So for accessing the static data and knowledge from websites, whether the websites are public or private, there are two options. You can either in a site into a data store in one go, right? Or you can have a function or extension that navigates the site. So in your opinion, what is the recommendation here? What are the advantages, disadvantages of both approaches?
So let me just take that. So either would work, but then let's just put into perspective what the first option does, right? So when you're just going to be ingesting information directly to a data store, which means that you would need to scrape the HTML code, and then you're just converting them into embeddings and then store them in a database, and then you will be just doing a RAG afterwards. So does it make that much sense to because that's still a kind of a language model, right? So what I would be choosing primarily is to have an extension or a function. Actually, even an extension would work of, let's say, for example, Google Search API, and then let the whole thing be handled by the Google Search extension instead of just storing anything, like everything, into a data store. I mean, there might be different considerations that you might want to be interested in using a data store. For example, if you have not a public but a private website, or you just want to be very specific about the information that you want to have it grounded directly. So there are some use cases where you might be interested in using it in a data store, but I would strongly recommend to scrape the text out of it rather than just dumping the full HTML code into the data store.
Okay, thank you very much. Anything to add on your side, or that's probably covers it. Okay, next one up is from Fernando. Fernando had a problem with the number of tools that he's using. I think it's also again more about the agents. So he's asking whether there's a recommended limit of tools that one should provide. So in his experiences, they have provided 8-9 tools options to a model, and it failed to call some of them quite often. So is it due to the prompt, or that's too many options and tasks, too many tools, and why that could happen, failing to call some of them?
I can take that one too. So, well, I mean, I love this question because it seems like somebody has already been trying agents in the background. So it's a great question to have. So I think this just goes back to the agent design that I mentioned around, for example, multi-agent structures, because basically this is kind of a trial and error. So everything is, being tested as we speak. But then what I would just recommend is to break down your agent into multiple agents and then just assign these tools to those sub-agents directly instead of just dumping everything into one. And then, yes, you're right. Then cognitive ability of the model can be like a constraint when you're just dumping all the 8, 9 tools into one. But then what I would recommend is just break down your task into smaller cognitive pieces, design associated agents with them, and then let them handle the tools directly. I don't think there's a very, let's say, universal number about how many tools that an agent should have. But the more that is, I mean, the thing is actually there's also this paradigm of also what models to choose for what agents. So maybe like sometimes you would be inclined to use smaller models because then you would like to save costs, and that would be not able to handle as many tools, or you would have a very large cognitive one just to do everything in one. So this is a quite a, well, it depends kind of an answer, right? But then I think it's a good question to ask to begin with.
I see, but I see also that the multi-agent and like splitting it to smaller chunks is the recommended approach over here.
Yeah.
Okay, I think we have one for Haren right now because it's about our beautiful Imogen. So Mohan is a founder of a startup that is building a virtual try-on for garments. So they need to retain some of the features of the garments and the features of the user. So the question is, can Imogen 3 be used where they can control the level of features of the source images to retain? I totally get that this is the use case for this virtual try-on, and they want to keep, my face, they want to keep my posture, anything like that, my hands with different t-shirts. So how Imogen 3 and whether Imogen 3 can help these days with this use case?
Thanks for the question. Right. So with Imagine 3, right? So we have had some customers who have done this sort of thing with some success, right? And again, this is like very much use case dependent. So I think it would be good to have like some good discussions with us, like maybe reach out to one of our CEs to discuss like use case in more details, right? But there are cases where this can be done, right? And of course there are some cases where you might need to add some fine tuning, right? And also with Imagine 3, so today I only talked about the features that's available today, right? And we are soon going to have like some image editing features, right, as well in the future. So I cannot talk too much details, and I hope that might address some of your needs, right? And again, like I said, this is very much use case dependent, and it will be best to have a little bit more detailed discussion with us to solve your problem.
Thank you for that. We have still a minute or two, so I'm gonna ask one more about the agents, I guess. It's coming from Ravi, and the question is, can you train the agent to simply recycle previous replies? I like the sustainability approach over here, because you don't need to come up with a brand new reply to every question if the question was similar earlier, and it saves some costs, some speed, I guess. So how does it work with training on the recycle?
So, I mean, it can be done, right? And I think that's also a good practice to do so. But then basically, it is again just going into the design of the multi-agent. So you can have a sub-agent, which might be deterministic, right? So you don't have all the agents to have a generative agent in the background, and then that agent can just dig in these replies somewhere stored in a database as an embedding, and then just extract them directly. Or like maybe just giving the floor to Harun as well, that we also have the context caching, right? So you can also just cache these contexts and then let the agent handle to retrieve whatever context has been cached, and then just use that one instead as well.
Okay.
From your side, Harun, maybe.
So like, this is, I think, a very typical caching problem, right? So caching, we've been doing caching for ages. So that there are so many things that's available, like, for web caching, for instance, people have been using CDNs for a long time, right? And so if you are talking about, like you got one question and there is only one answer available, right? And you simply want to return that, right? So that's a very simple caching problem that can be done, like, with multitudes of tools. But when it comes to LLM, I think you might be talking a little bit about, like, whether, okay, if there is a similar enough question, right? then there it becomes slightly more complicated. But for very simple, like okay, if question 1 and question 2 are exactly the same, and you want to respond exactly this in the same way, you can use any of these so many caching tools out there to solve your problem.
And I accept this as an answer, and I think that yes, the caching strategy, of course, also depends a lot on the use case. As always, depending on the use case, and we would probably need to take a look how often and how really similar these questions are to each other, and whether the answer is still a fixed thing. Gentlemen, we are at time. We're almost 1 minute after our program, and just out of the respect for all our users or our participants and their business appointments, thank you so much. Thank you so much for taking the time and sharing your knowledge. I saw in chat and on the Q&A panel a very good feedback for you. So very informative session. Even though it was complicated, even it was advanced, I think you laid it out all really great. Thank you so much for your participation. And to all of you watching Startup School with us, we see each other on Tuesday. Yes, this is the drill of Startup School. Next Tuesday, same time, we're going to totally change the topic, going a little bit out of the agents and chatbots. We're going to look at the big data sets. We're going to look at the BigQuery, a very powerful tool, and we're going to see how we can simplify the data exploration and boost our productivity using Gemini provided by Google in BigQuery. We're going to have 2 sessions on BigQuery. This is the intro one, and then the second one on Thursday. We're going to have Shai Alon, Startup Ecosystem Advocate from Google Cloud, joining us next Tuesday. And with that, thank you once again for showing up and for being with us. See you next week. Don't forget about the feedback form.